Hello, this is our fourth video of a series of 6 in this section 1.1 functions. And now we've kind of determined whether something is a function or not. Now we're going to go for what is the function's value at certain numbers. So this is evaluating a function, and over here, again, these are already functions. And notice the lettering here: h of x, g of x, even h of z. So these are all functions. Name of the functions are a little different on each one. This actually inputs x, this inputs z. If you notice, there's z's over here, and there's x's on this one because those are the input values. So notice the change, and sometimes they use different lettering, but it's the same idea. And but on these problems, like I said, this is just we already established that these are going to be functions. And over on those sections, we're going to be doing evaluating. So we're looking for the outputs. They're giving us the inputs, and we have to come up with the outputs. You're like, well, that's pretty easy. Well, most of them are. There's a couple down here that are a little trickier because you're putting in an expression for an expression. So it's a little trickier. If you notice, also notice I'm not, I know the letters of the alphabet. I just didn't want to do every single one of them. I'm doing 5 of them, and I think there's like 8 of them all together. So I didn't do A, and I'm not doing F and G. So, and I think there might be an I in there, but I'm not sure. But anyway, I'm not doing every single one of them. And but there's 2 problems from that section I'm evaluating. So 45 here has the same instructions, and these 4 has the same instructions as in finding the domain. Okay, so that's the groundwork here. That's what we're going to be doing. So the B here, we're going to evaluate f of 1. So all that matters here is just plugging 1 in, and you can use your calculator to find the output to help you out a little bit, so to do the calculation. So if you put 1 in, you get -2 times 1 squared plus 1 minus 1. So all I did was I dropped 1 in where there's an x. So that's all you're doing. So the output will be -2 times 1 squared, and that's -2, plus 1 minus 1, just they cancel each other out, and so the output is -2. So 1 gives me -2. Now remember from previous videos, that really creates an ordered pair. The ordered pair being 1 comma -2. So 1's the abscissa and -2 is the ordinate. So 1 -2 is an ordered pair. So that looks different from this, but that's really what's going on. So the next one now is put -1 in. So -2 times -1 squared plus a -1 minus 1. So this time I'm putting in -1 where I see an x instead of just 1. And so -2 times -1 squared is still -2. You can check me on the math there. And so it's -2 plus a -1, it's -3. And then minus 1 again is a -4. So the output turns out to be -4. All right? Now look at the remaining 3 though. You're not putting just a simple number in there now. You're putting in an expression, but that's okay. Instead of putting in the 1 or the -1 like we did B and C, you're placing -x in for that. So it looks like this: -2 times -x squared plus a -x minus 1. You're like, well, wait a minute. You're not going to get a -2 or -4. You're not going to get an answer like that. You don't. But you get out kind of what you put in. So in other words, what I'm saying, this is kind of this goes back to my growing up age. My mom always said, well, you get out your work, what you put in. I twist that a little bit and say, well, if I put in a number, I'm going to get out a number. Put in a lot of work, I get out a lot of that. If I put an expression in, I get out an expression. So I put in -x. Don't expect a number coming out of that. You're going to get an expression, and it's going to be in terms of x. So you get -2 times -x squared, which is -2x squared, plus a -x is a minus x and a minus 1. So I put in -x. I didn't put in a number. I put in a -x, which is an expression, so I get out the expression -2x squared minus x minus 1. It's hard for some people to think, who always think concrete. Hard for people to realize this, but I just look at it this way: put in a number, you get a number. Put in an expression, expect an expression. Not always that happens, but most of the time that's what happens. Now, the next one is -f of x. So you're not putting anything in other than x. You're like, well, that's great. That should be just the answer. Okay? But there's a negative in front. So what happens when you put a negative in front of something? Yeah, it takes the opposite of all the terms. So you're taking the opposite of what the function is. So it's like getting the function, put a negative here, and it's taking the opposite of all the terms listed. So it's not really evaluating anything other than x, but you're just taking the opposite. You're like, well, why is this problem in here then? You're not putting in something besides x. They want to show you that D and E do not give you the same answer. They want to show you that negative x here that negative doesn't just come out of this. Because when I get the answer to E, it's going to be remarkably different. Well, not remarkably, but it's going to be a little different than the one previous to that. So if I take the opposite of the function, it's going to be opposite of negative 2x squared plus x minus 1. So take the opposite of all the terms. And then that becomes 2x squared instead of a negative 2x squared minus x and a plus 1. So the only thing that's really the same is the middle term. The first and last terms are opposites. But the point I'm making here is they're different answers. So you can't just take the negative out or put the negative in. So taking the opposite of the input is different than taking the opposite of the output. And that's really the difference between D and E. So, and then H is probably the most difficult one to comprehend because you're putting in an expression for X that's bigger than the expression itself. So you're placing in X plus H into the expression. So it's going to be negative 2 times x plus h squared, because whatever's in the hopper is what I call it, the hopper, you place into the x up here. So if what's in the hopper is bigger than what x, so be it. So you put this right here into that x. So that's why I have negative 2 times x plus h squared plus the input. Well, what's the input? Well, the input is what's in the hopper, x plus h, and then minus 1. So if you look at all, just kind of go down the list, I'm doing the same thing on every single problem. I'm putting in what you're telling me to put in. So you tell me to put in x plus h, I'll do it. And that's exactly what I did. You're like, what are you doing now? You got to do the algebra. You got to clean up the math. So this is negative 2 times x squared plus 2xh plus h squared, when you FOIL x plus h squared out. And then plus x plus h minus 1. So the final answer is going to be negative 2x squared minus 4xh minus 2h squared plus x plus h minus 1. And there are no like terms. There is nothing to combine. So putting in x plus h made a mess of it because it gave you an expression that has 6 terms in it. Sometimes what will happen is some of these terms inside this expression will actually combine into one term, but there is no other x squared, there is no other xh, there is no other h squared, there is no other x, just x. There is no just h, and there's no other constant besides minus 1. So that is what it is. The next set problem is 45. Same premise, just a different function. I wanted to do a different one on this one just to show you that they're not all just polynomials. Sometimes they're fractions, but the means of doing it is exactly the same. So you plug in 1, so 2 times 1 plus 1 over 3 times 1 minus 5. So 3 is on top and negative 2 is on bottom, so it's simply negative 3 halves. So plugging 1 in, I got 3 on top and negative 2 on bottom and negative 3 halves. You're like, well, can I write it as negative 1.5 again? For me, that's just formatting. So if you want to write it as negative 3 halves, go for it. Negative 1.5, go for that one. I don't care which way it is. The only exception is if this is my math lab, they tell you to express it as a fraction, you need to write it that way. If they tell you to write it as a decimal, then you need to write it as negative 1.5. On my individual exams, I don't care which way you go with it. So to me, they're the same thing. But follow the directions, what's on the thing you're looking at. If it doesn't say how to express your answer, then you got freedom. You can write it either as negative 3 halves or negative 1.5 or negative 1.5 if they will accept that. So there's a lot of ways to write that. Negative 1, same thing. Put negative 1 instead. So 2 times negative 1 plus 1 over 3 times negative 1 minus 5. So 2 times negative 1 is negative 2, and negative 2 plus 1 is negative 1. And then 3 times negative 1 is negative 3, minus 5 is negative 8. And that simplifies down to 1/8. So negative 1 over negative 8 can be simplified down to 1/8. And 1/8 is kind of what I would expect from you guys, because I would expect you guys know the negatives would cancel each other out. And again, that's kind of a formatting thing to me. I mean, it's kind of shady, but it's 1/8 is what you should write down, and most of you guys should know that. So now putting in negative x, we get 2 times negative x plus 1 over 3 times negative x minus 5. So negative 2x plus 1 over negative 3x minus 5. Now the negatives don't cancel out on this one because it's an expression and there's not factored form, so nothing cancels. So what do? Just leave it. That's the answer right there. So the negatives don't cancel because of the plus and the minus that follows the x's. They're not factored form. So, and therefore you just have to leave it the way it is. And by the way, if that was a 10, I see this all the time. If that was a 10 and that was a negative 5, it still doesn't cancel. Because of the plus and the minus that's between them. You can only cancel if they're factors, and they're not factors. Nothing is factors here. So negative 2x plus 1 does not factor, and negative 3x minus 5 does not factor. There are no factors that cancel out. The only way you cancel fractions out is if they're factors. This goes back to math 103. So it's tempting to do it because it looks better, but it's not the same answer. Okay, and notice I put in a negative x, and I got out an expression. Now the next one, like the one, we kind of put an arrow over here because I'm running out of room a little bit. I'm going to put that over here. And what I'm going to do is just take the opposite of the function. So this one's actually the easiest one of the batch because it's just taking the opposite of what I started with. So it's the opposite of 2x plus 1 over 3x minus 5. Notice where the minus is at. It's out front because it's the opposite of the function. Now you can, and it doesn't matter if you do it or not, but that is the answer. But if you want, you can write it as negative 2x minus 1 over 3x minus 5. Now notice I took the opposite of 2x plus 1 only. Now that doesn't mean you take the opposite of the numerator and the denominator. That's very important, guys. A lot of people will take the opposite of the numerator, which is negative 2x plus 1, and then take the opposite of 3x minus 5 in the same motion. And you can't do that because when you take the opposite of the top and the bottom, you don't do anything. You just cancel each other out. So when you take the opposite of a fraction, you can take the opposite of the numerator. If you choose, which I don't know why you would want to do that, you can take the opposite of the denominator, but most people wouldn't do that. And but you can take the opposite of the numerator and leave the denominator alone. I always have a rule of thumb. If you're not sure, leave it that way. So that's your best bet. All right? Now, the next one is kind of like the h on the one above it, f of x plus h. You just plug in the x plus h in there. And so it's going to be 2 times x plus h plus 1 over 3 times x plus h minus 5. And really, the only thing you need to do here is to distribute the the numbers 2 and 3 in front of them. And so it's just going to be 2x plus 2h plus 1 over 3x plus 3h minus 5. You don't really gain anything doing that, but that's what it is. Nothing can be simplified. How come? Because they're not factors. Doesn't factor, no factors can cancel, then you have 3 terms on top and you have 3 terms on the bottom, and the only way you cancel is if you don't have the terms, you have factors. So, and there are no factors here. So anyway, that is 40 and 45, and that's just evaluating functions. Pretty simple. That's why they give you like 5, 6, 7, 8 problems in one problem. They're not long, or they are long. They're just not hard to do. So that's why they give you so many in one problem. Now the next 3 I would classify as probably a little easier, except maybe with the exception of number 62, because all you're asked here to do is find the domain. The domain's easy if you think about it. The domain is what's allowed to be put into the machine. Now, if you have a Pepsi machine, I keep bringing that up. What happens if you put a piece of cardboard inside the slot? Of course, you're not. If you push a button all day long, you're not going to get a soda pop out. Okay, you only get an output if the machine recognizes what you're putting in as acceptable. Okay, Well, in this machine, 48, this is a very liberal machine here. It will take anything you want to put into it. You'll square it, add 2 to it all day long, and spit out an answer. Okay? You put in 5, you're going to get 27. Put in 3, it's going to give you 11. Like, why is the domain all real numbers? Why isn't it a little bit more restrictive? Because there are no fractions and there's no square roots. So it doesn't have a problem with any number you decide to put into it. So the domain here is all real numbers. Now, I would accept interval notation, or I would expect this symbol right here, all real numbers, on exams. If you're in my math lab, they're probably going to want this top one. I'll put it in interval notation. So, or they'll have a button in it that says all real numbers or something like that. So it's just kind of what my math lab is asking you for. So now on 52, now this was a little bit more restrictive because you got to be careful because it has a fraction in there. 2x over x squared minus 4. Look at the, once I see a fraction, your eyes need to go right to the denominator. Okay, what makes the denominator 0? Sometimes it doesn't, anything makes it 0. If you had x squared plus 4 here, no problem. Because nothing will make x squared plus 4 equal to 0. Not even 2. 2 squared plus 4 is 8. That's not a problem. So just because you have a fraction doesn't mean you're going to have to exclude something. A lot of times that's the case though. So if you have x squared minus 4, what you have to understand, that can be 0. So when x equals plus or minus 2, that's a problem. Now, the domain is not 2 and negative 2, though. Don't get it mixed up. The domain is not what's asking is not allowed. What's not allowed? 2 and negative 2 is not allowed, because that's what makes the denominator 0. So what is it? Well, the domain is everything except the 2 and the negative 2. Now, your next thing is how to write that. So you can write it as an interval notation, negative infinity to negative 2, union, negative 2 to 2, union 2 to infinity. Yeah. So it's everything to the left of negative 2, everything in between the negative 2 and positive 2, and everything to the right of 2. So basically, if you look at it on a number line, here's negative 2 and here's 2. And if you can't include these two numbers, that means this number is not allowed and this number is not allowed. Okay? Then that means everything to the left of negative 2 is allowed, and that's what this interval is. Everything between negative 2 and 2 is accepted, that's what this interval is saying. And everything to the right of 2 is allowed. So that's what the domain is. So you can write it in interval notation. Another way you can write it with the real numbers, all real numbers except minus, take off, the plus or minus 2. Most people, this is their favorite way to write it because it's more compact, and so they enjoy that one a little better. Unfortunately, my math lab doesn't always take it that way. And they'll want you to write it this way or some other way, the formatting. And again, you got to follow their instructions. Now, g of x on 56 is the square root of 1 minus x. Now, square roots do not allow negative numbers inside because you get a complex. So whenever you see a square root, immediately you think, oh, okay, can't you have negative numbers inside there? So the radicand, which is the number inside, is greater than or equal to 0. Yes, that's what it's called. The number inside a radical is called the radicand. So you hear me say that every so often. The radicand is the 1 minus x in this case. So whenever you have a square roots, you set the radicand greater than or equal to 0 and solve that. So subtract 1, so you have negative x greater than or equal to negative 1. Subtracting 1. Divide both sides by negative 1. And so x is less than or equal to positive 1. You're like, why is it less than? Because you divided by a negative number. And I'm not going to spend a lot of time explaining to you why you have to flip it on this video. Suffice it to say, the magnitudes of the numbers change over. That's why you switch it. If you're in my traditional classes, I kind of show why. I'm at 19 minutes right now, and so I'm running out of time on this one. So just remember, you have to flip it over. So divide by a negative number, you flip the inequality symbol around. So it's less than or equal to 1 is what's acceptable. So in interval notation, it's negative infinity to 1 with a bracket. Notice the bracket is there. Bracket indicates that you include the number itself. So everything up to 1, but not past 1, is acceptable. So you're like, does that mean negative numbers are okay? Yeah. You're like, wait a minute, you just said negative numbers are not okay. Look what happens when you put negative numbers in. Put in -3 for x. Put in -3 right here for x. 1 take away -3 is 4. It's positive. So that's why the negative numbers are okay here, is because negative numbers, 1 minus a negative number, is a positive. So that's why it's okay, and you can take the square root of positives. So you cannot take the square root of negative numbers. That doesn't mean the x's can't be negative, because sometimes there's a negative in front of it, and it makes it turn to positive. Okay, and this one is kind of a combination of 56 and 52. 56 because there's a square root. 52 because it's a fraction. So you got to put them together. So this one here, the z plus 3 has to be greater than or equal to 0. So that's the radicand. Instead of greater than or equal to 0, so the z has to be greater than or equal to -3. But then the bottom says I can't divide by 0, so z minus 2 equals 0 when z equals 2. So let's put them together. The domain is greater than or equal to -3, but it can't be 2. So let's look at the number line. It's got to be greater than or equal to -3. So that's what that is saying. To the right of -3. But it cannot be 2. So it's got to be on to the right of -3, but it can't be 2. So as you can tell in the number line, it's going to be bracket -3, comma 2, union 2 to infinity, so because it breaks up into 2 pieces. This one is probably the most complicated of any type of problem that you're going to see when they ask you for the domain in this course. That doesn't mean that's the hardest one you'll ever see in your life. But in this course, this is probably about as hard as it's going to get. So it's to the right of -3, but don't include the 2. So that's what the domain is. So -3 to 2 means between here to here, and then 2 to infinity. Okay. So this concludes the fourth of the 6 videos that we'll see in this section. Thank you for watching.